So what happens, let's just run through these real quick. I don't care about the names of them, is irrelevant. This is called the, I don't even know what this is, product of powers, I think, but who cares? If you multiply two powers, I guess before we do this, this is the definition of a power. Like if we're talking about a power function. We'll talk about functions soon. It would just be f of x equals some coefficient times. Yeah, I probably would. I mean, the notes will be published. You decide. Every day I've been uploading these. You guys know where to find this stuff, right? Okay, when I'm done, remind me, and I'll just show you one more time. Because it's every day I upload this. It's all on the website. It's easy to get to. So a power function would be something like this, where we've got some number out front that we call a coefficient times a power, which is going to be some base to some exponent, right? So this is the power part. So let's focus on that. If we've got a power, what do we call that part? The base. Yep. And we call that part the exponent. Okay, so if we're multiplying powers, so for example, if we wanted to, let's just focus on what happens with the exponents. So if I do something like, let's say, a to the m times a to the n. Does everybody see that I'm multiplying two powers together? If they have like bases, so when I multiply like bases, what do I do with the exponents? Add them. Sure, that's it. Right, so this equals a to the m plus n. Very simple. Okay, questions? Okay, no biggie. All right, so while we're on the subject, what happens if we divide like bases? Good. So it's a to the m minus n. You could also write this, and this one doesn't show up in all the property sheets. This is kind of handy though. You can write it as 1 over n minus m. Now, why might you do that? Well, what if we had, for example, if I have x to the 7th over x to the 5th, I get what? X squared, right? Okay. Let's add another quick property up here. Real quick, what happens if I have a to a negative exponent? Remember?
1 over 8.
Okay. This equals 1 over a to the m. Okay. And along with that, if I have 1 over a to the negative m, what's that equal to? A to the m. So the way you think about this then is if you ever have in a fraction, right, there's two parts of a fraction, the numerator and the denominator. If you have a negative exponent in either part of a fraction, all you do is you chase it to the other part and make it positive, right? That's kind of the way you think about negative exponents, all right? So why do I bring that up? Because it relates to this previous one. So what if I have an example instead, like let's say x to the 4th over x to the 7th. What's that technically equal to? X to the, okay, good. But if we just follow the traditional quotient of powers rule, we end up with x to the negative 3, right?
You said 10.
Yeah.
Okay, what?
We said like 8 times yesterday.
I did? Well, you missed it. If you missed them, it's on you.
Oh.
Well, it does not show up.
It does show up. I can see it. Okay, question? Comment? Amber, do you have a quick question?
Oh, no, I was going to say.
Oh, you're going to tell me? Okay, thanks. I got to just strike that from my vocabulary. So then if we have a negative exponent, what do I do? Put it on the bottom. Okay, good. But now you see, a lot of times, we'll want to write things in terms of positive exponents. That'll be, for example, in Moodle, those will be the instructions, right? To write your answer in terms of positive exponents. So wouldn't it be nice to just skip from there over to there, right? So how can you come up with a general rule for this? Like just a rule of thumb as you're going through properties of exponents. How could you, a single rule that would, kind of cover both of these examples? Instead of saying you always subtract the bottom exponent from the top, or vice versa, what could you say? You mean subtract the smallest from the largest, you mean? Subtract the smallest from the largest and just put the base wherever it had the most power initially, right? So here, 7 is bigger than 5, so we keep the base on top and subtract 7 minus 5. Here, 7 is bigger than 4, so we keep the base on the bottom and subtract 4 from 7. And you see how that's really a better way to kind of think about it? Okay.
So much easier.
All right, so much easier, yeah. Okay, so what's next? How about if we do, let's see, what if we do a power to a power? Power of a power, I call this one. So if I have a to the m to the n, what do we do?
Multiplication.
Multiply. Good. So we get a to the m times n, okay? And what if we, what else, what have I not done? Okay, what if we have a power of a product? So if we do this, what if we have the quantity a times b to the m? What do you mean, add it to both? Okay, so I would effectively distribute the exponent to both factors, a and b. So a to the m times b to the m. Okay, make sense? Along with that, if I have a power of a quotient, what do I do? Say it again. Distribute it. Okay, good. What if I have any base to the 0 power? 1. Okay. So, rather than give you a bunch of specific examples, I'll maybe just show you one thing. Other than that, I don't think I'm going to let you probably deal with all this stuff. Well, maybe we'll go through, I'll pick like a couple of the hardest ones from the assignment, and we'll just look at those. What if we do, so I'm just going to pull up the assignment. Okay, so what I'm doing with these two, just on the more recent ones, instead of putting a Desmos calculator with everything, I just put one at the start. So you can just always go back to that if you like. Once I go to that page, if I open this up, I've just got it in a separate window anyway, so I can always go back to that window. Okay, it just makes it a little easier. All right, how about if we try more complex properties, these guys. Those aren't very hard. This is going to be a pretty easy assignment for you. Man, I thought I had a little tougher ones than that, but I guess not. Okay, there's nothing that hard on it. But I'm gonna make one up. What if you did this? Because this is something that you'll run into this year. Okay, there we go. How about that, guys?
Oh, thank you.
Give it to home.
That Z's a one. That Z on the bottom is a one.
Okay, what are we gonna do here?
You can flip them all.
Okay, here, oh, attention up here, please. Oh. Okay, so we gotta start by simplifying the inside, right? So we wanna do everything we can on the inside of these parentheses. Let's see, what are we gonna get? So we're gonna get the 12 over 8 is gonna reduce to,
Nope.
3 over 2, so 3 on top, 2 on bottom. What about the x to the 7 over x to the negative 2?
X to the 9.
Okay, x to the 9 on top, right? How about the y to the negative 3 over y to the negative 2?
Why the negative one? Put it on the bottom.
Okay, so yeah, now, and let's use our rule that we just talked about. What's greater, negative 2 or negative 3? Negative 2, so the y stays on the bottom. Negative 2 minus negative 3, 1. So you get y to the 1 on the bottom, which we wouldn't write, okay? And then z over z to the 0, just z. Okay, but if it's to the negative 2, before we even, well, you tell me, you tell me what I'm gonna tell you. What should I do next? Say it again? Flip it, yeah. If I have a fraction to a negative power, I just take the reciprocal to the positive power. That's a great trick, right? So immediately we would just rewrite this as 2y over 3x to the 9th times z to the positive 2. And now it's pretty easy, right? I'm just going to distribute the 2. How many factors are there on the top? 2. 2 times y. How many on the bottom?
1, 2,
3,
3.
right? 3 times x to the 9th times z. So we would just distribute the 2 to each of the factors on the top and the bottom. And what's that going to give us? So our final answer would look like 2 squared.
Y squared. 9.
18.
Right?
Z squared.
Okay, make sense? Go. Oh, do this before you start on this. Everybody come up, and you have to do this all at once. Just kind of filter up here. Here are the 2 handouts. There, I didn't staple them though. They're in order. Just staple a packet for yourself. You can have the rest of the period to work.
Are one of them more?